The next section is the alternating series test. This is the test you'll use whenever your series has signs that alternate. So if you have 1 minus a half plus a third minus a fourth, that's an alternating series because the signs alternate. So we actually talked about this series a little bit already. We called it the alternating harmonic series. The signs alternate, and on the very first day I said, so imagine I give you a full piece of rope and then I take away half of it, but then I give you a third of the original piece back, and then I take away a fourth of it, and I give you a fifth of the original piece back, and then I take away a sixth, and then I give you a seventh, and I take away an eighth. We said, well, you're giving and taking and giving and taking, but I can see that the amount of rope I have is eventually going to approach some number. And so that's the alternating series. This is the test for the alternating series. It has 2 parts. In order to use the alternating series test, you want to make sure that your signs actually do go back and forth, positive, negative, or negative, positive, but they have to go back and forth. If that's true, then you can start by taking the limit as n goes to infinity of your terms. And if you get 0, then you can also check to make sure that each term is smaller than the one before it. And I don't mean the sign, because I know that some of the terms are negative and some of them are positive. I just mean the magnitude of the term. And if both of those things are true, then your alternating series converges. Notice that if the first thing is false, if it doesn't equal 0, you're done, because that's the nth term test. Here's a diagram of kind of why it works. If I have a value, I add that value, and then I subtract something less than what I added, and then I add something less than what I subtracted, and then I subtract something less than what I added, eventually those sums are going to converge to a sum. Here's a more generic diagram of the same idea. Each term has to be smaller than the one before it because we're jumping back and forth, but we're not passing, like we're not jumping way out here. We're making closer and closer jumps back and forth to hit on the sum. All right, so here's an alternating series. Does it converge or diverge? So the first part of the test is we take the limit as n goes to infinity of our terms. And we get infinity. So that limit does not exist. So this series diverges by the nth term test. Okay, here's another example. Does this series converge or diverge? We're going to justify that as well. So the first part is the limit as n goes to infinity. Well, whether it's positive or negative, we have a very small number divided by infinity, so that limit is 0. So that's the first part of the alternating series test. And then the second part is if I look at without the sign, is the next term less than the previous term? And it is, because the denominator is bigger. So, and that's enough. So the alternating series test says that yes, it converges. These are the 2 parts. You check the limit of your terms, make sure you get 0. And if that fails, then you're done because of nth term test. And if that passes, then you check to make sure that your terms are each a little bit smaller than the one before. So that's the alternating series test. Thank you so much. Bye.